Okay, last but not least, electrolytic. Galvanic is spontaneous, and it's top right, bottom left on table 4b. Electrolytic is actually normally the same reaction with this, no, not the same reaction, the same metal, but it's either it gets oxidized at the anode and reduced at the cathode. So what's happening here is they're saying they electroplating ornaments with silver. So what happens is this bad boy over here must be the anode, and this must be pure silver. And this one gets oxidized, this one loses mass, so that this thing can get covered in silver. So what happens on this side is silver gets oxidized, and what happens on this side is silver gets reduced. So you end up with, So you end up with solid silver covering this thing on the left-hand side, and the anode is getting oxidized and making silver ions. And the energy conversion that takes place in the cell, it's electrical to chemical. You use a battery to force a chemical reaction to happen. The galvanic is the other way around. The galvanic, you use a spontaneous chemical reaction to make electricity. So galvanic is chemical to electrical. Electrolytic is electrical to chemical. It's like electrodynamics, where you do the motor and the generator. The motor is electrical to mechanical, and the generator is mechanical to electrical. This has the same kind of vibe in that the one does the one and the other one does the other one. So theoretically, if you study the one, the other one is the opposite. They say which terminal of the battery is negative. Now here, sorry guys, but there's another Terry table. So there's anode. Wow, that doesn't look good. Let me try that again. There's another Terry table. It's anode and cathode. And it is positive. Ugh, man, stupid. It is galvanic, galvanic and electrolytic. And once again, if you know the one, you can know them all. And the one that I choose to know is that the anode is positive. The anode is positive in the electrolytic, which means it's negative here, positive here, negative here. So I remember that the anode in the electrolytic cell is positive. So I remember that one, which means I can know all of them. They're asking which terminal of the battery, P or Q, is negative. This is the anode, so it's positive. And this is the cathode, so it's negative. The cathode in the electrolytic cell is negative. So it should be P. Yeah, there it is. And then write down the equation for the half-cell reaction that takes place at the cathode. What's true for both of them? Red cat is true for both of them. Reduction occurs at the cathode. So the reduction of silver ions is taking place at the cathode, at the rhino. And you can see it there. Ag plus gets an electron to make Ag. And then the marking criteria, what are they saying? Oh, it's all the different variations. So they say that it's okay if you don't have a charge of the electron. Maybe rather do it properly. You can't do these arrows. So these arrows are given to you on the table, but these arrows you need to answer properly with whether or not it's getting oxidized or reduced. So this arrow is saying oxidation and reduction is happening. Then, the very last question, unfortunately or fortunately, depending where you are, is stoichiometry. So stoichiometry is everywhere, like algebra is everywhere in maths, and it's 5 marks. So they want to electroplate the ornament with 3.25 grams of silver in 30 minutes, and they want to know how much current you need. So you have no idea how to do this question because it's your first time, but you are given a mass of silver. So what we're going to do is we're going to work out number of moles, because that's always what we do. So the number of moles of silver is 3.25 over silver, which is, okay, so silver is 108, and then you get 0.0300. Okay, so that's the number of moles of silver. Now they are asking you about current. Current, okay, here's a formula for current. It's charge over time. So now I have number of moles of silver, and they're asking me about charge or current. or time. So I have a time. The time is 30 minutes, and 30 minutes would then be 1,800 seconds. So you times it by 60 to convert the minutes into seconds. So I've got a number for that one. I need a number for charge. Hold on. Silver is getting 1 electron to make Ag. So if I have this many moles of silver, I have this many moles of electrons. And if I can know how many electrons, the charge of each electron is 1,6 times 10 to the minus 19. So I'm not sure if everyone will be able to get there, but I really enjoyed this question, which doesn't help you, I'm sorry. But if you want to work out the number of electrons, we times it by 6,02 times 10 to the 23, which is a mole, to get 1,806 times 10 to the 22 electrons. And that many electrons would have a charge. So you've also got this formula somewhere. That many electrons, 1,806 times 10 to the 22, would each have a charge of negative 1.6 times 10 to the minus 19 each. So you can get a total charge of negative 2889,6 coulombs. So that is how much charge you need in order to electroplate the ornament with 3.25 grams of silver. And you have 30 minutes. So the current you would need is the charge, which is 2889,6. I don't want to get a negative answer for current, so I'm just going to leave out the minus sign. And that's divided by 1,800, which means the current that I need is 1,61 amperes. So that's quite nice. Well, I enjoyed that anyway. I'm not sure anyone else did, but let's just see if I got it right. 1.61, woohoo! So you work out the number of moles of silver. You use that to work out the number of electrons, because the ratio is 1 to 1. Oh, that was a really nice question. Then you use that to work out the charge, and then you divide the charge by the time to get the current. So they really are getting creative with these exams. But anyway, this one is done. I'm going to start the next one now. I'm sorry if you're sad about that question, but if we just look here quickly, you get a mark for working out the time, which is just taking the 30 minutes and timesing about 60 seconds. So everyone can do that, I think. And you get a mark for working out the number of moles, which I have told you about a bazillion times you need to do. So if you're given a mass, you work out the number of moles. You're given a time, you convert it to seconds, because we always use time in seconds. And then, for the rest of it, it's maybe a bit much. But those 2 marks out of 5 is 40%, so we're passing. We really don't need to worry that much about science. We just need to find the formula, put a correct number in the correct place, and just be calm and happy and enjoy it. Although, I know.